Good evening, everyone. Today, I'm going to talk about a new and a promising approach to tackling the plastic waste crisis by upcycling PET waste using a technique that called ambient air oxidation. This method offers a more sustainable, efficient, and eco-friendly alternative to the traditional way we recycle plastic. What is the ambient air oxidation? This brings us to the solution. Ambient air oxidation is a chemical process that uses regular air, yes, the air around us, as the oxidation agent to break down PET waste. What is PET? Polyethylene terephthalate. It's a cleaner, low-energy alternative that avoids harsh chemical and create high-value material instead of low-grade plastic. Wait, let me show you a little simple video from Japan.
Japan. For many of us, a mystery. Westernized. The FP Corporation has been in the recycling business for more than 20 years now. At its facility in Gifu, it has specialized in PET recycling, most recently in the bottle-to-tray category as well. For this purpose, it uses a PET recycling line from Krones, a complete system comprising a washing module and a decontamination module. Up to 24 tons of PET bottles are processed here every day. In the first step, the PET bottles are fed to a vibrating screen. Smaller dirt particles are separated mechanically. In the second step, the material is passed through a metal detector bridge, enabling metals to be ejected at an early stage. In the grinder, the closure, PET and label materials are dry ground. The ground material then travels to a dry mixer, where the individual constituents are mingled with each other. In a zigzag sifter, the various parts are gently separated from each other, PET from the labels, for example. The product mixture of PET flakes and closure materials is then passed to the pre-washing unit, where it is mixed with warm process water and soaked. The process continues in the caustic washer. All residues sticking to the surface, such as adhesives or paper, are gently washed off by friction and removed from the washing caustic using filtration systems. The soiled caustic from the caustic washer is treated continuously in 2 stages in a Parsifal filter, after which the caustic can be reused. This is followed by a density separator. In a sink or swim process, the lighter closure materials are separated from the heavier PET flakes. The PET flakes sink to the bottom. Closure materials float to the surface and are removed. The PET flakes are now passed to a hot, multi-stage post-washing process, where they're very gently post-cleaned with heated fresh water. The washed PET flakes are then passed to a 2-stage dryer, where they're mechanically and then thermally dried using a hot air blower. The flakes are thereupon sorted by color, and any metal residues being magnetically removed, whereupon they're packed in big bags. This concludes the first stage, which is washing. It's followed by the decontamination module, which is designed to produce food-grade PET flakes. In the first step, the thicker neck particles are separated from the wall particles. The thicker and heavier particles are post-ground and returned to the remaining product flow. The aim is to create a maximally homogeneous PET product. Treatment then continues in the first heating worm, where the PET material is gently pre-warmed. In the second heating worm downstream, the flakes are heated up to the requisite decontamination temperature. This is followed by treatment and the actual cleaning process in the vacuum reactor, where all contaminants are removed from the products, thus creating food-grade flakes conforming to international standards. Finally, the food-grade flakes are sorted by color and packed in big bags. From the food-grade PET flakes obtained, new plastic trays and containers are produced. Krone's complete system solution, comprising the washing module and the decontamination module, proved persuasive for the client, which is why the FP Corporation decided to buy a second PET recycling line. Its installation will have been completed by the end of April 2012, and production can begin.
Let's continue to our topic, the PET plastic problem. Let's start with the problem, which is the plastic used in bottle and packaging, produced in huge over 82 million metric tons a year, but only about 30% of that is actually recycled. Traditional recycling method are energy intensive, don't fully break down the plastic and often lead to a loss in material quality. A process known as downcycling is contribute heavily to pollution and resource waste. How it works? Step 1. Collection and reprocessing of PET waste. Step 2. Oxidation reaction using ambient air at controlled condition. Step 3. Transformation into a high value product such as specialty, polymer or carbon-based material. Utilization in various industry, textile, coating, electronics. Then, it undergo an oxidation process in a controlled environment using ambient air condition. This reaction transforms the plastic to valuable material like specialty polymer or carbon-based compound. This material can be used in industry like textile, coating, and electronics. Now let's talk about the advantage over traditional recycling. Advantage over traditional recycling. Why it's better? Now let's compare this method to the traditional recycling ambient air oxidation. Ambient air oxidation use less energy, require fewer chemical, and produce high quality material. And most importantly, it has most lower environmental impact. In short, it's a smarter and greener way to deal with plastic waste. Application and market potential. The material created through this method have a real world value. They can be used to make a stronger fiber for clothing, lightweight components for cars and planes, or even conductive materials for electronic device, and as much more industry demand sustainable material. The market for upcycling PET is expected to grow rapidly. And here's one of our challenges and future prospects. Of course, there are challenges scaling this up for industrial use. Getting it approved by regulators and raising public awareness are all hurdles we still need to overcome, but the future looks bright. Research is ongoing to improve the process discovered, better catalysts, and possible apply this method to other types of plastic as well. Conclusion and call to action. To wrap up, ambient air oxidation is a game-changing approach to plastic recycling. It's energy efficient, eco-friendly, and produce valuable material. To support this kind of innovation, through this research, funding, and policy, we can take a huge step towards solving the plastic problem. Now, let's be part of the change.